Hello everyone, my name is Anushka Verma and I'm a civil engineering student at the Faculty of Engineering and Technology, University of Lucknow. Today, I'll be presenting on advanced flood control systems, a topic that highlights the critical role of engineering in mitigating one of the most persistent natural disasters, flooding. Let us begin with an overview of the topic. To provide a clear roadmap for this presentation, here is the table of contents. We'll begin by discussing the basic concepts of flood control systems, followed by an overview of essential civil engineering structures used for flood management. After that, we will delve into the history and evolution of flood control. Next, I'll present examples of advanced flood control systems worldwide, leading to two detailed case studies, the Dutch Delta Works and the Thames Barrier. Let's proceed to understand the fundamentals of flood control systems. Systems are essential for managing and mitigating the impacts of flood, which can cause significant damage to life, property, and infrastructure. These systems integrate various engineering and non-engineering approaches to protect both urban and rural areas from excessive water inundation. For example, the MOS project in Venice, Italy, is a remarkable flood defense system designed to safeguard the city from rising tides through innovative designs and strategies. Flood control system plays a crucial role in minimizing risk and ensuring safety. Flood management relies on several key engineering structures, like dams store and control water flow, creating reservoirs that aid in flood control. Sluices regulate water levels by allowing controlled water passage, while locks enables ships to navigate different water levels safely. Dikes or embankments prevent water from flooding inland, and storm surge barriers, like those in coastal areas, protect against high tides and storm surges. These structures are meticulously designed to ensure stability and efficiency in diverse conditions. History of flood control. The history of flood control is a long story of innovation and resilience, evolving over thousands of years. Let's begin with the ancient times. In Mesopotamia, early civilizations built levees and dams using earth, stone, and reeds to manage the Tigris and Euphrates rivers. They also developed irrigation systems with channels and dikes to protect settlements and enhance agriculture. Moving to Egypt, levees and dikes were vital for controlling the annual flooding of the Nile River. Indigenous systems of basins and channels dispersed floodwaters, preventing erosion while irrigating crops. The Romans added to this legacy with advanced aqueducts and drainage systems like the Aqua Maxima, which prevented urban flooding and supported large cities. Modern evolution. From the 9th century onwards, advancements in hydraulic engineering significantly improved flood control. Engineers began building larger and more resilient dams and levees to handle increasing water flows. By the 20th century, integrated systems combining dams, levees, flood walls, and retention basins became essential for managing urbanization and industrial growth. These developments set the stage for comprehensive flood defense systems that we witness today. Advanced flood control systems. The advanced flood control systems enhance the traditional methods through modern technology, like early warning systems, leverage satellite data and AI to predict and monitor flood risk. Deployed barriers, on the other hand, like the Thames Barrier, provide rapid protection against storm surges, while smart TVs and dams use sensor for real-time monitoring and adjustments. Green infrastructure, such as permeable pavements and urban wetlands, integrates nature-based solutions to reduce runoff and supply and support sustainability. Examples of modern flood control. Flood control engineering shines worldwide, like the Dutch Delta Works protects the Netherlands with massive storm surge barriers. London's Thames Barrier shields against tidal surges. Tokyo's flood tunnels quietly redirect rainwater underground. New Orleans' levee system combines levees, flood walls, and pumps to defend against hurricanes. Venice's most project lifts gate to block high tides. The Three Gorges Dam in China tames the Ganges River. These systems showcase human ingenuity in tackling the force of nature. Let's begin with our first case study, that is the Dutch Delta Works of the Netherlands. It is also regarded as the world's largest flood prevention system. Introduction. The Dutch Delta Works is a comprehensive system of dams, sloughs, locks, dikes, and storm surge barriers, designed to protect the Netherlands from flooding by controlling water flow in the southwestern river delta. Completed in 1997, the Delta Works is one of the most advanced flood defense systems in the world and serves as a model for flood prevention in coastal areas. The creation of Delta Works was primarily driven by the devastating North Sea floods of 1953. This flood overwhelmed existing coastal defenses, causing widespread destruction across the Netherlands. Over 1,800 people lost their lives and more than 100,000 people were displaced. The flood also inundated vital agricultural areas and industrial infrastructure, highlighting the need for a more reliable flood defense. In the response of it, the Dutch government initiated the Delta Works project to create a long-term solution to protect the nation from future floods, particularly given that much of the Netherlands lies below the sea level. Dutch Delta Works. This map illustrates the location of various key structures within the Delta Works. Each component plays a critical role in safeguarding the Netherlands from coastal flooding. This chart demonstrates the classification of various components of the Delta Works into major hydrological engineering structures, such as storm surge barriers, dams, dikes, sloughs, locks, and other auxiliary structures. Components of the Dutch Delta Works. The Dutch Delta Works consist of various key components, each playing a very crucial role in protecting the Netherlands from the rage of the sea. First, we have Oosterschelde, the world's largest storm surge barrier. It closes only during extreme weather, balancing flood protection with natural tidal flows. Next, we have Phillips Dam. This dam separates freshwater and saltwater bodies, aiding to both flood defense and ecological balance. Next is Mylansering, a massive movable barrier near Rotterdam that automatically closes during storm surges, ensuring city safety. Moving on, there up next we have the Harlingen sluice. These regulate water flows and salinity between the Northern Sea and the Harlingen estuary. Other structures like the Brouwerston Dam, Grevelingen Dam, Zarkeen Dam, and etc. each play crucial roles in controlling water levels and preventing flooding. Working of the Delta Works. The Delta Works is a remarkable system that protects the Netherlands by combining innovation and engineering. It begins with damming the estuaries, turning the vulnerable inlets into lakes that now serve as natural preserves and recreational spaces. Next, flexible barriers like the Mylansering stand ready to protect key waterways. These movable barriers close during storms to block surges, but stay open for everyday activities like shipping. Along the coast, reinforced defenses like grassy dikes and seawalls form a sturdy shield against ocean storms. Inland, the room for river plan creates floodplains by moving dikes and farms, giving rivers space to overflow safely while nurturing wildlife habitats. Finally, cities like Rotterdam showcase integrated urban solutions, green roofs, elevated districts, and plazas that could double as water storage during floods. Together, these measures ensure safety while adapting seamlessly to rising waters. Impact of the Dutch Delta Works. The Dutch Delta Works has significantly improved flood resilience, successfully preventing major incidents such as the North Sea storm surge of 1982, the storm of 1990, and the European floods of 2002. It protects critical infrastructure, agriculture, and urban areas, ensuring economic stability. The system supports sustainable water management, transforming areas into natural preserves while contributing to the Netherlands' carbon neutrality goals through efficient water use and recycling. Globally, it serves as a model flood defense system, inspiring similar projects in susceptible coastal areas. The triumphs and trials of the Delta Works. The Dutch Delta Works offers several advantages, namely flood protection, reduces flood risk, land reclamation, creates usable lands, economic benefits, safeguards infrastructure and property, environmental management, enhances biodiversity with nature-based solutions. It also possesses various disadvantages, namely high cost, expensive to build and maintain, maintenance needs, requires constant monitoring, environmental impact may disrupt ecosystems, false security, could reduce attention to other mitigation measures. Long-term goals for 2050 of the Dutch Delta Programme. The visions for 2050 includes achieving carbon neutrality, and three major investment areas are: number one, flood risk management, renovating dams, barriers, and coastline to withstand climate change is included in flood risk management. Second, drinking water supply, develop facilities for seawater desalination. Third, countryside redesign, adapt landscapes to handle droughts and floods. The program emphasizes sustainability and circular water use, promoting efficient resource management. Innovative projects like the Hyderloop project, which recovers 85% of the domestic water, and Witten's water recovery, which extracts reusable material from underground water, showcase the commitment to innovation and collaboration for a resilient future. Let's move on with the second case study, that is the Thames Barrier, that is located in London, England. Introduction. Let's talk about one of the most iconic flood defense systems in the world, the Thames Barrier. Located downstream of central London, between Silvertown and New Charlton, this engineering marvel protects 125 square kilometers of the city. It safeguards 1.25 million residents, landmarks like the House of Parliament, the O2 Arena, and a critical infrastructure such as Canary Wharf. Built to shield London from tidal surges and rising sea levels, Thames Barrier plays a critical role in ensuring the safety and resilience of this bustling metropole. The timeline and design. The story of Thames Barrier began with the North Sea flood of 1953, a devastating event that emphasized the urgent need for a robust flood defense system. Construction started in 1974 and spanned a decade, with the barrier officially opened by Queen Elizabeth II in 1984. The design is a feat of engineering brilliance. It consists of 10 steel gates, each weighing an impressive 3,700 tons, spanning 520 meters across the River Thames. Remarkably, it is designed to last until at least 2070, making it a long-term solution for London's flood risk. This image showcases a closer location of Thames Barrier. You can see its strategic position on the Thames River and its impressive structure. Operation and technology. So, how does the Thames Barrier work? The gates are raised during high tides or storm surges based on weather forecast and water level monitoring. These gates rotate upward, fully deploying within just 30 minutes, creating a sturdy wall against rising waters. Typically, the barrier is activated 6 to 7 times a year depending on weather conditions. In the control room, operators use real time data and predictive models to make an informed decision. This entire system is remote controlled with automated mechanisms ensuring precision. Maintenance is a top priority. Regular inspections and upgrades are carried out to ensure the barrier remains reliable and effective. Future and challenges. Like all infrastructure, the Thames Barrier faces future challenges. Climate change is causing sea levels to rise and increasing the frequency of tidal surges. While the barrier is expected to function until 2070, plans are already in place for upgrades or even a replacement. Researchers are exploring innovative solutions to enhance the defense around the Thames estuary, considers options like new barriers or advanced engineering technologies. While the Thames Barrier remains a crucial defense for London, addressing these evolving challenges will be the key to its continued success. References. This research won't be completed without some valuable resources. Information was gathered from trusted platforms like official Dutch Delta Works website, the Agency of Environment UK, Dutch Ministry of Infrastructure and Water Management, among others. I truly appreciate your time and interest in exploring the fascinating world of advanced flood control systems with me. Thank you for your attention and for being a part of this session.